It is the middle of December, and it is time to update my winter weather forecast I made at the end of October. This is the technical version, so I am going through my entire methodology and why I am predicting the things that I am predicting. If you just want the predictions, a second video will be uploaded at the same time of this with just the predictions. Disclaimer, this is long-range forecast and is intended to provide a general sense of what may happen in coming months. It is not that this is for sure happening, nor is it an excuse not to be prepared for a wind, snow, or ice storm, or any cold temperatures. Also, as a second disclaimer, my methodology is the same as it was in October, and therefore I do not use any weather models except for one particular statistic, which I was forced to use it for that. So I don't use any weather models for January or February time period in terms of trying to figure out how those months will go. This is to keep it as close to the October forecast methodology and to reduce error in between the two forecasts. I would be open to changing it in the future if I thought it was more accurate. Methodology, again, hasn't changed. I use an adjusted analog year approach using ENSO via the Oceanic Nino Index and confirm using the Southern Oscillation Index. Now, I have come across new sources in terms of the extrapolation of the ONI prior to 1950, so I have updated a portion of that in my data sets. The full update will come next year, as I was not able to update the entire data set, but I updated the years that were most closely related to this year, aka the strong El Ninos. Pacific and Atlantic multi-decadal oscillations I also use, and I also use the sunspot count to confirm which ENSO status we should be leaning. Analogs are also not weighted equally. Analogs that are closer condition-wise to this year's condition do have a higher weighting. Adjustments to analog years can also be made using statistical analysis. If there is a statistically likely or unlikely chance of something occurring, analogs will be adjusted unless if there's a clear trend in the analog year showing the opposite of statistic. I will also use general trends based on previous years, seasons, or months when appropriate. And while I do use analog years going back to 1900, the statistics only go back to 1940 because that's when the Portland airport data started. Snow prior to the 1970s have been adjusted to a 4.3 inch average per winter on analogs. That is the average snowfall that we have experienced since the 1970s, and that has been relatively stable. All forecasts will cover what has happened in 1 out of 3 winters at the Portland airport. So if I was just throwing darts, I would get about 1 out of 3 parameters correct in that case. Also, I do adjust temperatures in each decade to their decadal averages. So if you see, like for example, 1910, I adjust that year. So if you see that's 2 degrees above average, it's 2 degrees above the average that occurred in 1910, not 2 degrees above the today's average. Onto the data and oscillations updated for December. So the US's look at the ENSO outlook. So we are now officially in a strong El Nino with the latest November value coming out to be 1.8 degrees Celsius, the 3-month running average from the 3 previous months ending in November. And models are indicating that it will remain in a strong El Nino for this winter, but probably will taper off as we go into the spring and the summer months, with the CFS showing a steeper drop off compared to the US suite of models and some global models. When I do take a look at the global models put together by the Australian Bureau of Meteorology, their January outlook hasn't changed that much. Maybe it's 0.05 of a degree Celsius closer towards neutral than it was when I did this in October. But March had a marked change towards neutral, and rather being in the strong El Nino category, but not as strong as January. It's now in the moderate El Nino category, so it might not last as long as we previously thought, but I still think that a strong El Nino is going to be our primary atmospheric factor. So what happens during strong El Nino? And just to be clear, 7 out of 13 years had no snowfall. 3 out of 13 had more than 4 inches. The median was 0 inches. The average temperature, adjusted to each decade, was 1.5 degrees above average. No year has been below average more than 3/4 of a degree. Also, something else that I noticed is that every year that has had a below average temperature has either had their December being at average or below average. So that's not something that's going in our favor for a below average winter temperature wise. Media's lowest temperature was 22 degrees. There was 2 major Arctic blasts occurring in December of 1972 and December of 2009. And all other winters that did not contain a major Arctic blast had a temperature at or above 20 degrees. One winter did have a temperature below that, but after adjusting for the urban heat island comparison, that does bring that temperature a little bit above 20 degrees. The water-year rainfall median right at the long-term median. Bad mountain snowfall occurred below 4,500 feet. Okay mountain snowfall above, but still below average for the entire winter. So major windstorms in ENSO, just for a gauge, we're at about this 2 degrees Celsius when the peak of this El Nino happens, which should be about in a few weeks, though it's 3-month running average, so we'll see how those numbers pan out. And if you want a big windstorm, you want it either in the neutral category or a weak El Nino / a weak La Nina. With it being a strong El Nino, I find it extremely unlikely that we're going to experience a heavy windstorm anywhere in the Pacific Northwest, not just the Willamette Valley, which this is what this forecast is for. The updated Southern Oscillation Index last 5 years. Southern Oscillation Index, interestingly, is moved more neutral than it was back in October, where the September value is where my fake laser pointer is pointed at, and the current value at the end of November is where that small dip is. Pacific decadal oscillations the last five years. I didn't update this from October because it really hasn't significantly changed. We're still deep in the negative phase. The latest value is about -2. So it has come up a little bit, but I still do not see it flipping positive during this winter. The Atlantic multi-decadal oscillation, this is the most stable out of all the oscillations. This hasn't changed. I also did not see a need to update this chart considering I didn't see any change in values. Sunspot count, about 35% through the solar cycle. That does tend to favor El Ninos at this point. So that confirms that we should be seeing El Nino conditions-wise, atmospheric-wise. So looking to our analog years and our statistics, I did trim down the amount of analog years to 16 from the previous 21, and some analog years that were previously not on here are now on here. The top analog years have also changed. I reduced that from 5 to 4, with one top analog year, 1919 and 1920 from October, is not even a analog year anymore based on the ENSO reanalysis that I came across and comparing it to the previous sources that I had. The new top analog years are now 1911 and 1912, 1951 to 52, 1957 to 58, and 1965 to 66. Most of these analog years are El Nino, more specifically first year El Ninos in most of these cases. The exception is 1993 to 94, which was an ENSO neutral year. However, the SOI was in the negative the phase signifying the atmosphere may have been more El Nino-like, and the PDO started to show signs of a long-term flip to negative at that time. Now for our comparisons for our top analog years, 1911 and 1912 and 51 to 52 both had moderate El Ninos. The PDO for 1951 to 52 was negative. In 1911 and 1912, it was technically neutral. However, it was tilting negative values-wise, as all the values that occurred the last 6 months of 1911 and the first 6 months of 1912, was all negative, but not strong enough negative for me to firmly say that it was in the negative phase. Ammo was in the positive phase for 1951 to 52. In 1911 and 1912, it was briefly in the positive phase. However, that time period was majority negative, so take this one with a grain of salt. Sunspot progression, 1911 and 1912 actually favored a La Nina with that solar sunspot progression, but the rest of these favored a El Nino. Oh, and the other analog years had a strong El Nino. Now, in comparison, the PDO was neutral for the strong El Ninos, and again, I mentioned this in October, we have not seen a strong El Nino with a negative PDO. We have seen a moderate El Nino with a negative PDO, but even that is pretty rare. So we're in uncharted territory here, and that does increase the error of long-range forecasts. Extreme events during these top analog years, 1911 to 1912, wasn't a dud in Portland. There's minor snow in November, followed by 8 inches in January, but if you were in Eugene, it was a dud. This didn't stop above average temperatures occurring during the winter, with it being about 2 degrees above the 1910s average, and precipitation was near average for the winter. 1951 to 52 is the most interesting winter of the bunch, with it being consistently but not extremely cold in December and January. There was 9.6 inches of snow, mostly in January. Eugene had a little bit less. 1957 to 58, it was a dud all around. 4.2 degrees above the 1950s average, which is the highest departure from average recorded at the Portland airport, though not downtown. Interestingly, that departure from average was a La Nina year. And then 1965 to 66, while it was a dud in Portland with less than an inch of snow, it did maintain near average temperatures. But in Eugene, there was 7.7 inches of snow, 2/3 of which was in December, mainly the latter half of December, rest of which occurred in March. The departure from averages from each analog year, again, adjusted to each decade, a larger tilt towards above average was noted in this batch of analog years compared to my October ones, especially the top and analog years, and after my weighting formulas as for which year was the closest compared to the furthest. So the all analog median was about 0.8 of a degree above average. The top analog median was about a degree above average, and weighting it all came out about 0.5 degree above average. Water year precipitation, most of the years came out near normal, with the remainder of the years being a slight tilt below normal. However, because a lot of these years did have a positive PDO, that does mean that the precipitation values might be skewed a little bit lower compared to what they should be, because a negative PDO like we're in actually increases our precipitation. So the all analog medians, 33.74 inches, the top analog median about the same, and the weighted analog median about the same. Lowest wintertime temperature, the all analog median was 22 degrees, the top analog median is 21 degrees, and the weighted analog is 22.5 degrees, all of which are about the same as they were previously, with the exception of the weighted analog. Adjusted snowfall, the all analog median has actually gone up slightly to 1.45 inches. The top analog median and the weighted analogs both went down to just a titch above 2 inches. Now, for the historically significant trends and statistics. There's been 8 consecutive winters that have had measurable snowfall. This is a record high. A chance of it occurring this winter in Portland is a 5.3% chance. This statistic does only apply to Portland. This does not apply to Eugene, as their current streak of measurable snowfall, I believe, is only at 2. Only 3 winters have produced a temperature under 20 degrees with less than 1.5 inches of snow. All 3 of these had 0 inches. 2 of these were El Nino winters, with 1941 to 42 being a moderate and 1976 to 77 being a weak El Nino. 3 consecutive winters have also had 6 inches or more measurable snowfall in Portland, and the chance of a 4th occurring is 2.5%. And this is an unadjusted chance. If I change it to adjusted, the chance does go up when I go back to 1940. But if I'm using just the year since 1970, so the amount where, or the snowfall average evened out, it does come out to right around this 2.5%. So, and lastly, a new statistic for December for the water year. If the water year contains 18 inches or more by December 31st, there's a really good chance that there will be 40 or more inches of rainfall on the entire water year. I bring this up because currently we're about 2.5 inches above average for the water year. However, I did take a look at the forecast models, and while I don't like to make a forecast for 2 weeks out typically, looking at the atmospheric water content and what I'm expecting, I do not think we hit 18 inches for the water year. And for context, at that point, that is about 3 inches above average for the water year at that point in the season. And the water year runs from October 1st through September 30th of the following year. So, on to the predictions. Starting off with the basics here. The water year, I'm predicting a near median water year favored, though I did raise the prediction compared to the October prediction, with now the new prediction being 33 to 41 inches, or within about 10% of the median, with winter being slightly increased to 14 to 17 inches. My best estimate is 35 inches for the water year. Temperature departure above normal is favored. I am not anticipating it being a historically warm winter necessarily, though. I'm just anticipating up to 3 degrees above average, with my best estimate being 1 degree above average. Windstorm, I'm expecting now a pretty tame year with a peak gust less than 49 miles per hour. We're getting past that time where during an El Nino, a significant windstorm can happen. As in October, I did note that a windstorm would most likely happen during the earlier part of the season, and one does not look to be on the horizon. Lowest temperature above 20 degrees. Best estimate is 25 degrees. That has gone up since previously. Also, another thing to note with windstorms, with my change in analog years compared to October, that also reduced the amount of years that actually had any significant windstorms in general. Most likely to be active December 25th through January 25th, and also March 1st through March 10th was a secondary peak. Both of these were pretty weak correlations. I actually think it's more likely that there's no active time, but this is where it is most likely to be active, so I am putting these in here just in case. So for the mountain snowfall, snow depth on April 1st, I am anticipating it being a little bit below normal, anywhere from about 60 to 100% above 4,500 feet. In the lower elevations, anywhere from about 50 to 85% of normal. And then for the valley snowfall, I am thinking it will be below normal valley-wide. The best estimate is a trace. This is now regardless of location. And the chance of a no-snow winter has been increased to 75%. So that is it for this. Assuming these predictions verify, there's a good chance that there's not going to be any event that is considered severe enough to trigger a forecast video. If not, the latest I will talk to you all is going to be in March for the winter forecast verification. If I don't talk to you then, please, regardless, stay safe out there and take care.